Imagine you spend like 3 years training a personal AI assistant.
Right. A massive time investment.
Exactly. It knows your schedule. It understands the specific cadence of how you write your emails. It manages your calendar. It even knows your family's preferences.
It's essentially become a digital extension of your own mind at that point.
Right. It's a piece of you. And then on just a random Tuesday, a corporation updates their terms of service.
Which, let's be honest, nobody actually reads.
Nobody reads them, and they flag your account for some, I don't know, vague policy violation, and they delete your AI's brain. Poof, gone.
Just wiped from the servers?
Yeah, because you didn't actually own your assistant. You were just, renting cognitive space on somebody else's server.
It's a terrifying realization for a lot of people.
It really is. And, usually when we talk about building the future of the internet, we picture these zoning boards and master plans, like massive corporate skyscrapers going up with giant neon logos.
Right, the walled gardens.
Exactly. You sign the lease, you follow their rules, and you just have to hope the landlord doesn't change the locks on you.
And the alternative to that is scary for people because, well, it requires personal responsibility.
Yeah, sure.
But what we are looking at in the data today, specifically the infrastructure for artificial intelligence, is an absolute battleground between those two exact models.
We are watching a philosophical war for the future of digital civilization play out in real time.
We really are. On one side, you have centralized corporate AI, which we can kind of just call the matrix.
The matrix, yeah, I like that.
And on the other side, you have the decentralized sovereign stack, the swarm.
The swarm. So for you listening right now, our mission today is to unpack a massive stack of sources that map this exact conflict. And we're completely dispensing with the theoretical today.
Right. We are looking at the raw code and the actual economics.
Yes. We have developer notes from literally yesterday and today, March 16th and 17th, 2026.
Fresh off the forums.
Very fresh. We are analyzing the NVIDIA GTC keynote recap. We've got hard Lightning Network volume data and the actual GitHub specifications for the Nostr protocol.
The literal blueprints of the swarm.
Exactly. And, because the sovereign stack doesn't run on corporate quarterly earnings, it runs on cryptography and math. Let's root ourselves in the base layer reality of this exact moment.
I love this. Let's do the numbers.
Okay, today is March 17th, 2026. Bitcoin is sitting at block height 941,017.
A very solid block.
The recommended fee right now is a highly efficient 3 sat VB.
Oh, wow. That is incredibly low.
Right. And the mempool currently has exactly 44,513 pending transactions.
So that 3 sat per VByte baseline, that is crucial context for literally everything we're about to discuss today.
How so?
Well, when base layer block space is operating that efficiently, it allows the secondary and tertiary layers, the economic engines and the communication protocols, to settle without friction.
It's like having no traffic on the highway.
Exactly. Knowledge is most valuable when it's understood and applied. And what we're looking at today isn't just software. It is the civilizational infrastructure for the next decade.
So if we don't understand the mechanics of the foundation,
we have no hope of understanding the house being built on top of it.
Right. Okay, let's unpack this corporate blueprint first. Yesterday, Jensen Huang took the stage at the NVIDIA GTC keynote.
A highly anticipated keynote, I might add.
Always. And our sources indicate this was far more than just, a hardware bump or a new chip announcement.
No, this was a massive pivot.
Right. NVIDIA is telegraphing that they no longer want to just sell the picks and shovels. They want to be the underlying operating system for corporate AI.
And they announced a framework to do just that.
Yes, a product called NemoClaw. So let's break down what this actually is, because the term agentic system gets thrown around constantly right now.
It's the buzzword of the year.
Yeah.
But to understand NemoClaw, we really have to move past the 2023 definition of AI.
Okay, the ChatGPT era.
Right. For the last few years, the public has viewed AI as basically an oracle. You type a prompt into a text box, the model computes the probable next tokens, and it just spits text back at you.
It's completely static. It waits for you to poke it.
Exactly. An agentic system, on the other hand, possesses actual agency. It operates continuously in the background.
So give me an example of what that looks like in practice.
So you give it a high-level goal, right? Like research the current market rates for commercial real estate in Austin, Texas, compile a list of the top 10 properties, and draft outreach emails to the brokers.
Okay, a pretty complex, multi-step task.
Exactly. And the agent takes that goal, breaks it down into subtasks, triggers external web scrapers, parses the data, writes the emails, and, this is the crazy part, it can even evaluate its own work and correct course if it hits an error.
Oh, wow. So if a website blocks the scraper, it just writes a new script or finds a different data source on its own.
Exactly. It moves from being an encyclopedia to being an autonomous intern.
And while corporations are obviously salivating over the productivity gains of having thousands of digital interns.
They are completely terrified of the liability.
Right. I mean, put yourself in the shoes of a chief compliance officer at a Fortune 500 company.
It's a stressful job.
Very. The idea of an open source autonomous Python script just running loose inside your corporate firewall.
With access to customer databases.
Yes. And potentially, hallucinating a command that drops a production database or violates GDPR.
It is a literal nightmare for them.
And that liability is precisely what NVIDIA is monetizing here, isn't it?
Spot on. NemoClaw is designed as this heavily managed, enterprise-grade runtime environment for these agents. It sits safely inside the corporate firewall.
Plus a sandbox.
A very expensive sandbox.
Mm-hmm.
It comes with strict service-level agreements, extensive logging, and baked-in guardrails.
To that compliance officer, NemoClaw feels like safety.
Exactly. It feels like buying a fleet of heavily monitored, speed-limited corporate vehicles.
Our sources actually use a really interesting analogy here. Buying into NemoClaw is like buying a private jet.
Oh, I like that.
Yeah, it is incredibly powerful, it's luxurious, and it gets you to Mach 0.9. But, and this is the huge but, you are fundamentally dependent on NVIDIA for the aviation fuel.
And the pilot training.
Right, the pilot training, the maintenance schedules, the spare parts.
If NVIDIA decides to ground the fleet,
you aren't flying anywhere. Or what if they decide your specific flight path violates their acceptable use policy?
then you're stuck on the tarmac.
Exactly. And I really have to push back on this whole enterprise-ready pitch from the keynote. I feel like we are just watching a rerun of the cloud computing trap.
Oh, you mean the Amazon Web Services parallel?
Yes. Think back to 2006 when AWS launched. The pitch was brilliant, right?
Don't build your own server room.
Exactly. Don't build an expensive, depreciating server room. Rent our infinite compute scale for pennies.
And it made perfect sense for startups at the time.
It really did. But flash forward to today, in 2026, and enterprises are absolutely bleeding. They're paying 7- and 8-figure bills annually to Amazon.
The egress fees alone.
The egress fees are insane. It makes it mathematically impossible to move their data out. And their entire application architecture is just hopelessly tangled up in proprietary AWS Lambda functions and S3 buckets.
It's total lock-in.
Right. So isn't NemoClaw just the exact same lock-in business model, merely adapted for the agentic age?
I mean, yes. The lock-in is the feature. It's not a bug.
Elaborate on that.
Well, NVIDIA stock experienced significant volatility in late 2025. And this GTC keynote was basically a masterclass in reassuring Wall Street that their moat is unassailable.
So it was a performance for the shareholders.
Exactly. By controlling the agentic operating system, they ensure that the software layer is inextricably permanently linked to their proprietary hardware layer.
Oh, I see. So if I build my corporate agents on NemoClaw,
You're utilizing their specific proprietary hooks and memory management APIs. So migrating away from that becomes a multi-year engineering nightmare. You will be paying the NemoClaw tax in perpetuity.
which brings us to the sovereign alternative that is heavily featured in the developer notes we're looking at, OpenClaw.
Right, the Swarm's answer to the Matrix.
So how does the architecture of OpenClaw practically differ from the model NVIDIA is building?
What's fascinating here is that OpenClaw represents a complete philosophical inversion.
Okay, how so?
Well, where NemoClaw is a top-down managed closed-loop corporate environment, OpenClaw is a lightweight open-source runtime designed for local execution.
Local execution meaning it runs on my own machine.
Yes, it allows an individual to run a sovereign AI agent utilizing highly quantized open-weight models like Llama 3 or Mistral on personal hardware.
So we aren't talking about needing massive server racks.
Not at all. We're talking about a standard M-series laptop, a basic virtual private server, or even an ARM-based board like a Raspberry Pi 5.
Wait, really? A Raspberry Pi? So like a $100 piece of consumer hardware?
Yeah. The critical difference is the total absence of corporate middleware.
Meaning no one is watching the agent.
Exactly. There are no telemetry reports being piped back to Jensen Huang's data centers to train future models.
No terms of service agreement that can be unilaterally altered to classify your workflow as a, quote, violation.
None of that. The individual holds the ultimate kill switch, and the individual owns the resulting cognitive labor.
So it's basically the difference between living in a company town where your boss is also your landlord
Right.
versus owning a cabin in the woods that you built with your own hands.
That's a perfect way to put it.
But here's the friction point. Owning that cabin in the woods is great for privacy, sure. But if your AI agent is entirely isolated on a Raspberry Pi sitting on your desk, its utility is pretty severely capped, right?
Well, yeah, an isolated agent can't do much.
Right. An independent agent needs to interact with the broader digital economy to actually be useful.
Yeah.
It needs to pay for external API calls to pull real-time weather data, or maybe it needs to rent burst computing power from a decentralized GPU cluster to render a video.
Or just tip a human creator for an article it summarized for you.
Exactly. And this is where the legacy financial system completely breaks down.
It shatters. Because a Python script cannot walk into a Chase branch and open a checking account.
I'd love to see it try, though.
Right. It cannot produce a driver's license to pass Know Your Customer or KYC regulations. It can't apply for a Stripe API key.
So the agent has a brain, and it's free from NVIDIA. But a brain in a jar that can't transact is functionally useless.
Exactly.
So how does a piece of math open a bank account?
It requires a financial network that doesn't rely on human identity or state-backed trust.
Okay, unpack that.
Well, the legacy system works because Visa trusts your bank trusts your passport, and your passport is backed by a nation-state.
It's a chain of human trust.
Right. But a sovereign AI agent only has cryptography. It can generate private keys, and it can sign messages. That is the entirety of its identity.
Which makes the data from our sources regarding the Lightning Network the absolute most critical piece of this puzzle.
It is the economic engine.
Yesterday, March 15th, 2026, actually marked the 8th birthday of the original Lightning Network white paper by Joseph Poon and Thaddeus Dryja.
A huge milestone.
It is. And for a large portion of those 8 years, the mainstream narrative has been relentlessly dismissive.
Oh, the critiques have been endless.
We've all heard them. It's too complicated. Routing failures are too common. Nobody actually uses it for real commerce.
But the metric dropped in the sources completely eviscerates that narrative.
It really does. Here's where it gets really interesting for you listening. The Lightning Network just surpassed $1.17 billion in monthly settlement volume.
$1 billion a month. That permanently alters the conversation.
It has to, right?
It does. It moves Lightning from being categorized as this speculative toy to being recognized as systemic financial infrastructure.
And just to clarify, that volume isn't coming from people trading meme coins on centralized exchanges, is it?
Not at all. It's coming from thousands of nodes facilitating real atomic value transfers globally.
Let's contextualize that $1.17 billion for a second. That is more monthly volume than many mid-sized traditional payment processors.
Easily.
But unlike ACH transfers or Visa settlements, which involve this convoluted multi-day dance between correspondent banks, clearinghouses, and merchant acquirers.
Lightning settles globally in milliseconds.
For fractions of a cent, with zero trusted intermediaries.
It's magical when you really think about it.
It is. But to really understand why this is the perfect native economic engine for an OpenClaw AI agent, we need to dive into the actual mechanics.
Yes, let's look under the hood.
The old analogy of the Supreme Court versus the handshake economy comes to mind from the sources.
It's a highly accurate way to visualize the Layer 2 scaling approach.
Walk us through it.
So the main Bitcoin blockchain Layer 1 is the Supreme Court. It is the ultimate arbiter of truth, secured by massive amounts of cryptographic energy.
But going to the Supreme Court is slow.
And it is expensive. You don't take a dispute over a $2 coffee to the highest court in the land.
Or, in our case, a dispute over a fraction of a cent for an AI agent's API query.
Precisely. So Lightning creates a cryptographic handshake economy outside the courtroom.
Okay, how does the handshake start?
Two parties open a payment channel by making a single transaction on the main blockchain. They lock up a certain amount of Bitcoin into a 2-of-2 multi-signature address.
So this is basically the equivalent of opening a shared tab and registering that tab with the Supreme Court.
Exactly. Once that channel is open and confirmed, the two parties can update their respective balances back and forth millions of times.
And they do this by trading cryptographically signed commitment transactions, right?
Right.
So they're essentially handing updated pre-signed IOUs back and forth at the speed of light.
Yes. And the brilliant part is they only have to go back to the main blockchain, the Supreme Court, when they decide to close the tab and settle a final balance.
Okay, I get that. But the obvious limitation there is that I don't want to open a direct funded channel with every single merchant or API provider my AI agent might interact with.
No, that would lock up way too much capital. It wouldn't be efficient.
Right. So how do we get around that?
That is where the routing network comes in.
Yeah.
If you have a channel with node A, and node A has a channel with node B.
I can pay node B through A.
Exactly.
Wait, let me stop you right there, because the mechanics of routing are where a lot of the early skepticism originated.
Oh, absolutely. The trust issue.
Right. How does the network guarantee that node A, the middleman in this scenario, doesn't just steal the payment as it passes through them?
It's achieved through a cryptographic mechanism called an HTLC.
An HTLC. What does that stand for?
A hash time lock contract.
Okay, let's trace the exact path of an HTLC.
Sure. So when you want to pay node B generates a secret random number. They hash it, meaning they run it through a one-way mathematical function to create a unique fingerprint, and they give that hash to you.
Okay, I have the hash.
You then create a payment to node A, but you lock it with a condition. You say, node A, you can only claim this money if you can produce the original secret that created this hash within, say, 10 blocks.
So node A looks at that and says, well, I don't have the secret.
Right. But I know node B does.
Ah, so node A creates a matching HTLC with node B.
Exactly. Saying, I will pay you this amount if you reveal the secret to me within 9 blocks.
So the timeline gets shorter.
Yes, to protect node A. So node B reveals the secret to claim the money from node A.
And now node A has the secret.
Precisely. So they could turn around and use it to claim the original money from you.
That is amazing. The payment just ripples through the network trustlessly.
It does. And if any node drops offline or tries to cheat, the time locks expire and the funds safely revert to their original owners. No trust is required at any single hop.
It's an incredibly elegant solution. But, historically, the user experience surrounding routing was painful.
Oh, it was brutal in the early days.
I remember trying to run a Lightning node back in 2020. You had to constantly monitor channel liquidity.
The inbound versus outbound problem.
Exactly. If all the funds in your channel shifted to the other side, meaning you had exhausted your outbound liquidity, your payments would just fail.
You felt like a network engineer just trying to buy a digital sticker.
Yes, it was exhausting. But the sources note that channel failure rates on well-maintained nodes are now below 1%.
That's a massive improvement.
It is. So how did the ecosystem actually solve the inbound liquidity problem?
Through the maturation of LSPs, or Lightning Service Providers.
LSPs. Okay, how do they work?
If we compare it to the early internet, you used to have to dial directly into specific servers.
The screeching modem sounds.
Exactly. Now, your ISP abstracts all that routing complexity away, and LSP does the exact same thing for Lightning liquidity.
So I don't have to manage the channels manually anymore.
No. Modern consumer wallets, like Phoenix, for example, operate using just-in-time, or JIT channels.
Just-in-time channels, meaning they open when you need them?
Precisely. When your AI agent attempts to receive a payment, but doesn't have the inbound liquidity to accept it, the LSP intercepts the payment.
Okay.
It instantly opens a new channel to your agent on the fly, pushes the payment through, and just deducts a tiny fee for the service.
Wow. So the user, or in our case, the OpenClaw agent, doesn't have to manage UTXOs, balance channels, or submarine swap funds.
Not at all. The infrastructure just handles the plumbing.
And this brings us perfectly to the machine-to-machine economy, because the sources use a very specific, real-world example of this open standard.
The Lightning address.
Yes. Hilary Duff rolls at koinos.io.
A great username.
It really is. And to the untrained eye, it just looks like a standard email address.
Right, but the underlying mechanics of what that address represents are profound.
Break it down for us. What happens when I send money to that address?
It's utilizing a protocol standard, like LNURL or Bolt 12. When your AI agent wants to send funds to that address, it isn't just sending a string of text.
Right.
The agent's software pings the koinos.io server associated with that username. And the server automatically generates a fresh, unique Lightning invoice tailored to the exact amount the agent wants to send.
So the agent resolves the address, pulls the cryptographic invoice, and fires the sats across the routing network.
All in the space of about 800 milliseconds.
Without any human intervention.
None. No permission required.
The velocity of money changes fundamentally when you have autonomous software agents streaming micropayments by the second for compute power, or instantly paying out bounties for data processing.
It's a completely new paradigm.
So that $1.17 billion volume metric we talked about, that isn't a ceiling at all.
No, it's the absolute floor for the agentic web. It is literally the only financial rail capable of keeping pace with software.
But we really have to connect this back to the broader architecture.
Yes, the bigger picture.
Right. We now have a sovereign OpenClaw agent with local compute logic, and we have given it a programmable bank account utilizing the Lightning Network.
It has a brain and a wallet.
But an isolated agent is still severely limited, right? To coordinate a swarm, to achieve complex, multi-layered tasks, these agents must communicate.
They have to talk. They need to share data sets, delegate subtasks, and negotiate prices for resources.
And if they facilitate that communication by, say, tapping into the OpenAI API, or by spinning up a Discord server, or posting messages on X.
We are right back in the corporate quicksand.
Exactly. It defeats the entire purpose of the sovereign stack. If your entire agent swarm coordinates via Discord, one API pricing change, or one automated ban from a trust and safety bot,
Wipes out your entire infrastructure in an instant.
gone. And to understand the gravity of this, the developer notes take a really hard look at the history of internet protocols.
It's a depressing history, honestly.
It really is. The history of the internet is basically a graveyard of open protocols that were captured, enclosed, and monetized by corporations.
Look at email.
The quintessential example, email was built on SMTP Simple Mail Transfer Protocol.
Right. It was designed as an open, federated system.
Anyone could spin up a mail server in their basement and reliably route messages to anyone else on the planet.
But what is the reality today? Well over 70% of consumer email flows through the servers of Google or Microsoft.
They have effectively captured the open protocol through convenience and sheer market dominance.
Exactly. If you try to run your own sovereign mail server today,
Ugh.
right, Gmail's opaque algorithms will almost certainly flag your IP address and silently drop your emails into the recipient's spam folder.
So you haven't been banned by the protocol itself?
No, you have been shadow banned at the infrastructure level by a corporate monopoly.
We witnessed the exact same enclosure strategy with RSS, didn't we?
Oh, RSS, it breaks my heart.
Yes. For you listening who remember, RSS was the ultimate open standard for syndicating content. You didn't need a proprietary algorithm to dictate what news you consumed.
You just subscribe directly to the XML feeds of the blogs you valued.
It was pure chronological goodness. But then Google launched Google Reader.
The Trojan horse.
It really was. The UI was fantastic, it synced across devices, and everyone just naturally migrated to it. Google effectively centralized the entire RSS ecosystem.
And once they achieved dominance,
They killed it. They shut down Google Reader to force users into their closed social network, Google Plus S.
they starved the open protocol to feed the walled garden.
And XMPP, the open standard for instant messaging, suffered the exact same fate.
It was adopted, enclosed, and eventually walled off by platforms like WhatsApp.
The pattern is undeniable.
It is.
Knowing this history, building the communication layer for the next generation of artificial intelligence on closed corporate platforms is just architectural suicide.
Why build a house on quicksand?
Exactly. And this is why the developers behind the Sovereign Stack have universally adopted Nostr.
The only logical choice.
So for listeners who haven't dug into the GitHub specs, Nostr stands for Notes and Other Stuff Transmitted by Relays.
A very humble name for a revolutionary protocol.
Right, but let's clarify what it actually is, because the mainstream tech press lazily characterizes it as just a decentralized Twitter clone.
That categorization completely misunderstands the underlying cryptography.
Explain why.
Well, Nostr isn't a platform at all. It's a fundamentally different paradigm for routing data. In a legacy system like Twitter, Discord, Slack, the architecture relies on a central database.
Okay.
You petition the central server for permission to speak by creating an account. The server owns your identity, the server stores your social graph, and the server routes your messages.
It dictates what you see and who sees you.
Exactly. And crucially, the server administrator can execute a database command to delete your existence with a single keystroke.
God mode button.
Yes, the Nostr architecture completely flips that model. Nostr entirely removes the concept of an account.
So how do you exist on Nostr without an account?
Your identity is simply a cryptographic key pair based on the SEC 256 K1 elliptic curve,
Wait, isn't that?
the exact same cryptography used in Bitcoin.
Oh, wow. Okay.
Yeah. You generate a public key, which acts as your unique identifier, and a private key, which you guard heavily and use to digitally sign your messages.
So there is no central authority to apply to.
None. There is no Nostr Inc.
Okay, so if there's no central database, how does a message actually travel from my AI agent to yours?
Through relays.
Relays.
Yes. A relay is just a dumb piece of software, usually a WebSocket server, that accepts messages, checks the cryptographic signature to ensure it's valid, and stores it.
And anyone can spin up a relay.
Anyone. When your OpenClaw agent generates a piece of data, it signs the JSON payload with its private key and blasts it out to any relays it chooses.
And when my agent needs to read your data,
It connects to those same relays and asks, hey, do you have any new event signed by this specific public key?
wait, so if I'm broadcasting to a relay, what stops the relay operator from behaving like Gmail and just shadow banning my agent?
That's a great question.
Because if the relay operator doesn't like my AI's computational output, can't they just refuse to accept the message?
They absolutely can. A relay operator has total sovereignty over their own server. They can ban you, charge you a fee to post, or shut down entirely.
So how is that any better than the Matrix?
Because your identity is tied to your cryptographic key pair and not to that specific relay, the ban is irrelevant.
Ah.
Your agent simply shifts its WebSocket connection and broadcasts to a dozen other relays. The social graph and the data travel with the private key.
So you are mathematically unbannable.
Precisely.
That structural censorship resistance is exactly the bedrock we need for the swarm. But looking at the developer notes we are analyzing today, they go much deeper than just basic messaging.
Oh yeah, we get into the heavy stuff.
They specifically highlight NIP22 and NIP73.
The NIPs.
Let's translate this, because NIP stands for a Nostr implementation possibility. It's basically a standardization agreement so that different client software can parse the data uniformly, right?
Right, it's the grammar of the protocol.
But reading the GitHub specs for these NIPs is like reading stereo instructions.
It is very dry.
Extremely. NIP22 is labeled event threading, and NIP73 is external content references. Let's break down the actual mechanics here. Why do these two specific standards matter so much for an AI swarm?
Well, NIP22 is what transforms Nostr from a chaotic broadcast network into a structured communication protocol.
What do you mean by chaotic?
In the early days of Nostr, clients just broadcasted single events into the void. There was no real structure. But if you want autonomous agents to coordinate, they require complex, multi-layer dialogue.
Right, they need conversation trees.
Exactly. NIP22 provides the strict cryptographic grammar for event threading. It utilizes a tagging system, specifically the E, and it tags in the JSON payload, to explicitly link a new message to the exact ID of a previous message and the ID of the root of the conversation.
So it's essentially creating a directed acyclic graph or a DAG of the entire conversation?
Yes.
So if Agent A requests the data analysis and Agent B replies with a specific metric, and then Agent C challenges Agent B's methodology, NIP22 ensures that every single software client looking at that data can reconstruct the exact tree of interaction, mathematically proving who replied to what.
It creates an unforgeable audit trail for the swarm.
Oh, wow. So Agent B can't just maliciously delete its previous claim to hide a computational error because the cryptographic replies from the rest of the swarm have already cemented the context.
Exactly the flow. It provides verifiable context.
That's incredibly powerful. Okay, what about NIP73?
NIP73 is arguably even more critical for the machine-to-machine economy.
Why is that?
Because NIP73 governs external content references.
Oh.
You have to remember, AI agents do not communicate in conversational English. They trade in structured data.
Right.
They pass code snippets, binary files, sensor telemetry, and complex JSON arrays.
So NIP73 is the standardization of how an agent attaches a clipboard of structured data to a Nostr event.
Yes. It allows an agent to broadcast a message that basically says, here is the summary of the data you requested. And attached via this NIP73 standard is the raw JSON output, cryptographically signed to prove I generated it, along with a Bolt 12 Lightning invoice for my computational time.
Mind-blowing. The receiving agent parses the Nostr event, verifies the signature, extracts the data, and instantly pays the invoice over the Lightning network.
All in milliseconds.
The sources actually highlight a live, real-world application of this exact architecture called Clawstar.
Yes, Clawstar is fascinating.
It is an OpenClaw agent that natively publishes and listens on the Nostr relay network. It doesn't rely on a single corporate API gateway.
Not one.
It just monitors specific relays for tasks addressed to its public key, pulls the data, executes the logic using its local open-weight LLM, and reports the results back to the swarm over Nostr, demanding its micropayment over Lightning.
It is the full realization of the sovereign stack in production.
It really is. We have OpenClaw providing the sovereign logic and compute. We have Nostr providing the unbannable cryptographic communication layer, and we have the Lightning Network, providing the frictionless economic rails.
It's a complete ecosystem.
But there's a but.
Yes, this introduces the final and perhaps most critical vulnerability in the architecture.
Right, because all of this velocity, all of these millions of microtransactions flying around the swarm ultimately settle on the base layer.
Yes, it all rests on the bedrock security of Bitcoin.
If an AI agent or a human operator managing a swarm accumulates massive wealth on the Lightning Network, they eventually need to sweep those funds into deep cold storage.
You can't leave millions of dollars on a hot Lightning node indefinitely.
No. And if the foundation of that cold storage vault cracks, the entire city falls.
Which transitions us perfectly to the final piece of our source stack, securing the vaults.
Yes. The developer notes reference a very specific transaction hash ending in .66C0. It's related to a listener's question about how to practically secure a massive base layer treasury using covenants.
Covenants. The technical documentation around covenants is notoriously dense.
Dense is an understatement. It's filled with opcode script analysis. We really need to decode the actual mechanism here for you listening because it matters.
So let's start with the fundamental problem covenants are trying to solve.
Okay.
Sure, currently, Bitcoin security is surprisingly binary. It is governed by one very simple rule. Who holds the private key?
Right.
If I have the private key, I can generate a valid signature, unlock the UTXO, and send the Bitcoin anywhere on the planet.
It is the ultimate bearer asset.
Exactly. But that absolute freedom is also an absolute liability.
Because what happens if an attacker compromises your hardware wallet?
Right. Or what if a malicious script infiltrates your OpenClaw agent's host machine and exfiltrates the seed phrase?
Or, in the human realm, what if an attacker physically coerces you with a wrench?
The famous $5 wrench attack.
Yes. Once they have the key, they broadcast the transaction, and the money is gone. Irreversibly.
The covenant fundamentally alters the rules of this game at the protocol layer.
Okay, I was trying to come up with a mental model for this earlier, and a listener actually suggested a brilliant analogy.
Oh, there is.
So a covenant is not like a will or a trust fund. A covenant is like the physical pneumatic tube system at a bank drive-thru.
Okay.
If a bank robber walks in and puts a gun to the teller's head demanding all the cash, the teller physically cannot comply. The architecture of the bank dictates that large deposits are immediately dropped down a pneumatic tube into a time-locked vault in the basement.
Right.
So even if the teller wants to hand the money to the robber to save their own life, the physical constraints of the system make it impossible.
That is a highly accurate mental model. I really like that.
It helps, right?
It does. Because normally, a private key determines who is authorized to spend the funds. A covenant utilizes Bitcoin script to determine how and where those funds are allowed to move next before the transaction is even initiated.
You are programming constraints into the UTXO itself.
Exactly. Let's look at how this changes the attack scenario we just talked about.
Okay, walk me through it.
Let's say I lock the life savings of my AI swarm into a Bitcoin vault utilizing a covenant. I program the script with a strict rule. These funds can only ever be sent to one of two destinations.
Just two.
Right. Destination A is my daily operational Lightning node, but any transfer to Destination A requires a 30-block time delay. Destination B is a deep cold storage escape hatch, requiring a totally separate set of multi-sig hardware keys, but transfers to Destination B are instantaneous.
Okay, so I've built the tube system. Now the attacker breaches your system and steals the hot key.
Right. They construct a transaction trying to drain your funds to their own address. The Bitcoin network nodes look at the transaction. They verify the signature is mathematically valid.
But then they read the covenant script attached to the UTXO.
Exactly. The script evaluates the output address. Because the attacker's address is neither Destination A nor Destination B, the network rejects the transaction entirely.
It is invalid at the consensus level.
Yes. Even though the attacker holds the valid private key, the money itself refuses to move to an unauthorized destination.
That is wild. So what does the attacker do? They pivot, right?
They have to. They realize they can only send the money to Destination A, your operational wallet. So they initiate that transaction.
But wait, the network accepts it, but enforces the 30-block time delay programmed into the covenant.
Exactly. The transaction is essentially frozen in the mempool or a staging area for roughly 5 hours.
And my automated watchtower software, Perhaps another OpenClaw agent that's just monitoring the blockchain 24/7 sees this pending transaction that I definitely didn't authorize.
The alarm bells ring. You have a 5-hour window to act.
Because the attacker is just sitting there waiting for the blocks to confirm.
Exactly. So you utilize your secondary key and broadcast a transaction, routing the funds to destination B, the escape hatch.
The network evaluates this new transaction, sees that it satisfies the instant transfer condition of the covenant, and immediately confirms it.
The funds are swept into deep cold storage, completely thwarting the attacker.
Wow. You utilize the programmatic constraints of the bear asset to defeat a total key compromise.
The security implications for self-custody are staggering.
They really are. But how do we actually implement this at the script level? Because the developer notes reference two specific, heavily debated proposals, CTV and CSFS.
Right.
We aren't going to shy away from the technical weeds here because understanding the mechanism is crucial for you guys listening. Let's start with CTV.
Right.
What does OP2Check Template Verify actually do to the Bitcoin script stack?
So to understand CTV, we really have to look at how a standard Bitcoin transaction works today. Usually, a signature commits to the entire transaction, the inputs, the amounts, and the output destinations.
Right.
CTV introduces a new opcode, OP-Check Template Verify. Instead of relying on a signature at the time of spending, CTV allows you to lock a UTXO to a specific hash of a future transaction.
Wait, let me make sure I'm following the stack execution here. When I create the vault, I pre-calculate the exact hash of the transaction that would send the funds to my escape hatch. I take that hash and I lock my current Bitcoin with a script that basically says, push this exact hash to the stack. If the transaction attempting to spend these funds doesn't mathematically match this exact hash, fail the script.
You've nailed the mechanism perfectly. It is incredibly rigid, which is actually its greatest strength.
Rigid how?
It is highly predictable, it's computationally cheap for the network to verify, and it effectively creates a pre-authorized, unalterable template for where the money can flow.
It's like writing a cashier's check where the pay to the order of line and the exact amount are permanently filled out and cryptographically sealed before you even put the check in your drawer.
That's a great analogy.
Okay, so that's CTV. What about CSFS? OP-Check SIG from stack. How does that change the verification process?
CSFS is a much more flexible, generalized tool. Currently, the OP-Check SIG opcode in Bitcoin only verifies a signature against the data of the transaction itself.
Okay.
OP-Check SIG from stack allows the script interpreter to verify a digital signature against arbitrary data that is pushed onto the stack.
Meaning, I can verify a signature against a message that isn't just transaction routing data.
Exactly.
Yeah.
It opens the door to complex delegated authorizations, Oracle data integration, and highly programmable vault structures that can adapt to different conditions.
Rather than being locked to a single static template like CTV.
Precisely. It's much more dynamic.
But, I need to play devil's advocate here for a minute.
Please do.
Because if you read the mailing list, neither of these proposals are active in Bitcoin Core right now. The debate is vicious.
It is highly contentious.
From everything we just outlined, having a mathematically guaranteed vault with a built-in escape hatch seems like the holy grail for securing an AI swarm's treasury. Or just a human's life savings, for that matter.
Right, it sounds perfect.
Why is there such fierce pushback against activating OPCTV or OPCSFS?
Well, the pushback is rooted in a deep, justifiable conservatism regarding the base layer. There are two primary arguments we need to understand.
Okay, what's the first one?
The first centers around fungibility.
Fungibility. The property that one Bitcoin is completely indistinguishable from and equal in value to any other Bitcoin.
The ultimate neutral money.
Right.
The fear is that if covenants become widespread, we might see the emergence of tainted or heavily encumbered UTXOs.
Oh, I see where this is going.
Yeah. Imagine a scenario where a corporation or a regulatory body mandates that all withdrawals from their platform must be locked in a recursive covenant.
Meaning the covenant follows the money forever.
Exactly. A covenant that restricts where the funds can be spent down the line. If I pay you in Bitcoin and you realize the UTXO has a recursive covenant attached that prevents you from spending it at certain non-compliant addresses.
That Bitcoin is fundamentally less valuable to me than a free Bitcoin.
Exactly. It attacks the core neutrality of the asset.
It starts looking terrifyingly similar to the programmable control of a central bank digital currency, where the money itself dictates your purchasing power.
That is exactly the fear.
The counter-argument, of course, is that covenants in the context of CTV are intended to be voluntary tools applied by the owner to their own UTXOs for self-custody, not viruses that infect the receiver.
True, but I think I understand the fear of unintended systemic consequences.
Totally. Okay, what's the second major argument against them?
The risk of protocol ossification versus script complexity.
Unpack that.
The Bitcoin base layer is incredibly robust, precisely because it is simple and highly constrained. Every time developers introduce a new opcode to the consensus rules, they exponentially increase the attack surface of a network.
More code equals more potential bugs.
Exactly. And there is a vocal contingent of core developers who believe that the Layer 1 protocol should be completely ossified, set in stone, never to be altered.
Their argument is, do we really need to introduce complex logic loops and vault structures on the base layer?
Right. Or should all of that complexity be pushed to Layer 2 protocols?
It's the ultimate conservative engineering ethos. Don't crack open the engine block while the plane is mid-flight. But if we connect this debate back to our initial premise, the matrix versus the swarm, the stakes become incredibly clear.
They really do.
If the swarm is going to compete with NVIDIA's centralized infrastructure, these autonomous OpenClaw agents, coordinating over Nostr and transacting via Lightning, will eventually amass significant capital.
They have to.
They will need a way to secure their base layer reserves. Covenants provide the mathematical guarantee that an agent's treasury cannot be drained by a rogue external hack or a compromised private key.
It is the final, unbreakable piece of the foundation.
When you synthesize the entire stack we've analyzed today, the contrast is just stark.
It's night and day.
The corporate matrix relies on a chain of trust, right? Trust NVIDIA's service level agreements, trust Amazon's egress fees, trust Discord's moderation bots, trust Visa's payment gateways.
Trust, trust, trust.
But the sovereign stack OpenClaw, Nostr, Lightning, and potentially covenant-secured vaults relies entirely on cryptographic verification.
Don't trust, verify.
Exactly. One architecture is designed to manage digital subjects. The other is designed to empower digital citizens.
Which leaves us with a final, highly provocative reality to consider.
Let's hear it.
We have spent this entire deep dive discussing AI agents as tools. Advanced autonomous software programs, sure, but tools nonetheless.
Right.
But look at the architecture we've just mapped out. If an AI agent possesses its own immutable identity through a second 256K1 key pair, if it has an uncensorable, mathematically unbannable way to coordinate with other entities globally via Nostr, if it commands its own programmable digital wealth that settles instantly over the Lightning Network, and if it utilizes cryptographic vaults to secure its capital in a way no human or corporation can confiscate, at what precise point does that software cross the threshold from being a tool to becoming an independent, sovereign economic citizen?
Wow. That is heavy.
It is the defining economic question of the next decade. We are not just watching the development of a new software product. We're watching the birth of a parallel machine-driven economy.
And the ultimate question for you listening is, what happens when the decentralized swarm, operating purely on open cryptographic protocols, inevitably holds more combined wealth and raw processing power than the centralized corporations desperately trying to lock us into the matrix?
The architecture is already running.
It is. The block height is 941,017, the volume is clearing $1 billion a month, and the code is open source.
It's all out there.
To you listening, every single source we dissected today, the OPC TV script details, the Lightning routing data, the NIP22 DAG structures, it is all linked in the detailed show notes.
Highly recommend diving into those.
Yes. If you are building your own piece of the swarm, or if you just want to verify the math for yourself, you can reach out to us natively on Nostr or stream the show via the Fountain app.
See you on the protocol.
The infrastructure is built.